We are now starting question number 3 of this paper M1 9709 oblique 42 May June 2023. The question statement is coplanar forces of magnitude 30 Newton, 50 Newton, 33 Newton, and P Newton acts at a point in the direction shown in the diagram where tangent of alpha is equal to 4 over 3. The system is in equilibrium. Show that 14.4 over 30.30 minus p whole square plus 28.8 over p plus 30 whole square is equal to 1. Since all these four forces are in the coplanar plane, so we know one thing. We will first find out all horizontal components, they are being balanced, and all vertical components, they are also being balanced in this question. So first of all horizontal components, we will draw this figure into parts and then we will find out the solution of this one. Now, let's say this 15 Newton force is going to be resolved into two components. This is 15 sine of alpha and this is 15 cos of alpha. This force is 30 Newton. So it is like this. So this will be known as 30 cos of theta and this will be 30 sine of theta. Same is this, you resolve it into components. Then this component is P cos of theta and this component is P sine of theta. This component would be 33 cos of alpha and this will be 33 sine of alpha. Now we are going to use all horizontal components. They are being balanced. So for this forces, this 33 cos of alpha is acting towards right side and 15 cos of alpha is also acting on the right side, which is being balanced by this 33 cos of theta is on the left side and this P cos of theta is also on the left side of that. But they have shown it that tangent of alpha is equal to 4 by 3. So if it is angle alpha there, tangent of alpha means what? Perpendicular over base. So this is length 5 because being calculated by the right angle triangle there. So sine of alpha will be equal to 4 over 5 and cos of alpha is equal to 3 over 5. Now we put these values into this 33 as it is into cos of alpha there is 3 by 5 plus 15 as it is. Cos of alpha is again 3 by 5 is equal to 30 plus p into cos of theta. So we know from this part, from the calculation, 33 plus 15 so 30 plus p into cos of theta is equal to 28.8. So from this, we know that cos of theta is equal to 28.8 over 30 plus p. Let's say it is equation number 1. Now we use all vertical components. The upward component is 15 sine alpha, and this upward component is 30 sine theta, which is being balanced by the downward components, that is 33 sine of alpha plus p sine of theta. Now 15 sine of alpha minus 33 sine of alpha is equal to p sine theta minus 30 sine theta there. It is 15 minus 33 into sine of alpha value is equal to p is common here, sine 30 sine theta p minus 30. So sine alpha is basically equal to 4 over 5. That thing is equal to sine theta into p minus 30. So this value is basically equal to minus 14.4 is equal to sine theta into p minus 30. We can write this thing as sine of theta is equal to minus 14.4 over p minus 30. Or you can write this thing as 14 minus 4 over 30 minus p is equal to sine theta. Let's say that is equation number 2. We know from this trigonometry that sine square theta plus cos square theta is equal to 1. So we put the values into this equation. So it will be equal to 14.4 over 30 minus p whole square plus 28.8 over 30 plus p whole square is equal to 1. And that thing we are going to show in this first part of this calculation there for the angles and the forces there. Now for the second part, verify that P is equal to 6 satisfies the equation and find the value of theta there. So if P is equal to 6, then first you have to verify and then you are going to find the value of theta for this part. So when P is equal to 6, then cos of theta is going to be equal to 30 cos of theta B part. Cos of theta is now equal to 28.8 over 36, and that value is equal to 28.8 over 36, that is 0.8. Sine of theta is basically equal to 14.4 over 30 minus 6, that is 24, and that value is equal to 0.6. If you put this value and this value into this equation of cos square theta plus sine square theta is equal to 1, then we know that that thing is equal to 0.8 square plus 0.6 square. That thing is equal to 0.64 plus 0.36, and that is equal to 1. So first we have to prove this thing, and we are going to verify that P value is equal to 6. Then you are going to find out the value of theta from this part. So you can put in this equation, let's say it is 5. We know that cos of theta is equal to 28.8 over 36, and theta is equal to cos inverse of 28.8 over 36, that is 0.8, and that value is equal to 36 point 36.86. This thing is equal to, for one decimal place, is 38.9 degrees for the value of theta to this problem there. So this is question number 3 of the forces are in equilibrium. So you have to keep this thing in your mind that when they are in equilibrium, then all upward forces are balanced by the downward forces and all rightward forces are balanced by the leftward forces. And whatever the calculations you get it from that, you can use it in it and you can get the solution to that problem.